Hello all. Today we will be going to solve this daily LeetCode problem, sorted distance after road addition query 1. Let me quickly explain you the problem first. So we are given an integer n and a 2D array queries. This n represents cities from 0 to n minus 1, and it is given that there is an unidirectional road between city I and I plus 1. So if we are having, let's say, n equal to 5, so 0 1 2 3 4 5, so there will be a road between I to I plus 1 in a unidirectional way, one way. This additionally we have given this queries as well, represents additional unidirectional road from city UI to VI, and after each query we need to find the shortest length between the city 0 to n minus 1. So ultimately we need to find what will be the shortest path between 0 to n minus 1. Let's say n is 6 over here. Yeah, so n minus 1. So we need to return answer after using the first I plus 1 query. So let's say if we have given this query array which contains 3 elements. So if we use this first one, which is 2 to 4, so if we are having path, let's say, from 2 to 4, so what will be the sorted distance? It will be 1 2 and 3. That's why we have written 3 over here, and now we are having this 0 to 2 as well. So if I use this 0 to 2, then my path will be 1 and 2 only. So 2 will be over here, and I can directly jump from 0 to my n minus 1. So the answer will be 1 only. Yeah, so this is explained over here as well. So how we can solve this problem? So we know that after each query I got one additional path, and what this additional path will do for me, so this additional path will allow me to come at some point from some other point, right? So what I can do, I can store this endpoint for, let's say, 4. What will be the path that I can come from? So it will be 2 only, so I can save 2 over here. Similarly, when this got updated, I got 0 as well. So for path this, I will be having 2 and 4. So I can use both of these for part. For this city 4, I can use either I can come from 2 or either I can come from 0. So whichever gives me the minimum will be my answer. So what I mean by this is that I keep on iterating on queries, will update my path array for any endpoint. I keep on adding elements in it, and I will calculate the new distance from the starting for each point from I up to n minus 1. How I can do it? How can I do it? I can use one, let's say, dp array. For any I, it will be minimum of dp I minus 1 plus 1, or whatever path are given by my query, or any endpoint. what are its initial points. So let's say if it is j and initial point is 0 plus 1, right? And whichever gives me the minimum will be minimum for reaching at ith point. And at the end, what I can do, I can store it in some vector. So where I use the first ith elements from query array. So how much distance I need to travel for reaching from 0 to n minus 1. And I can return my final vector answer. So let me quickly code this out. Yeah, so as I said, we can create one dp array. So it will store the shortest distance from 0 to any city I, right? And let's assign value 0 to all the elements of it. Now I can use one path vector which will basically store for any endpoint how many initial points are there from where I can reach out to it other than I minus 1, all that are stored in this query array. So now I need to keep on using, sorry, I can keep on using my elements from query array, and we'll see what will be the minimum distance for reaching I minus 1 city by using first I queries. So I need to use it. So how can I use it? So I can insert in my path array for query ith query. I will be storing in my end path what will be its initial path, what will be its initial city where I can reach from. So it's 0. Now once I do it, I need to find the minimum distance. So I need to do it for all the cities up till n. So I already mentioned this dp of j be first I can reach from dp of j minus 1 plus 1. So we all know that we are having path from j minus 1 to j. So from reaching j minus 1 to j I need additional 1 distance. So that what I have considered over here. Now I need to find key from path array how many initial point I can reach for this endpoint j. So dp of j can be minimum of dp of j comma and dp of k, the initial point that I can reach from, plus 1, right? And after all this, I can store whatever value of dp n minus 1 after considering the ith query, means considering all the queries from 0 to I minus 1, what will be my answer in dp I minus 1. I can store it my answer vector. So let me use the answer vector as well, then I can return simply answer. This need to be here, I think. And now I can return simply my answer. So let me run this. Yeah, both of are correct. Yeah, so it's submitted as well. So let me quickly explain you the time complexity for this problem. So over here we have used these queries that we are traveling in, and we are going through all the n elements, and we are going through all the values that are in query as well, and we are doing it for only once for all n numbers. Let's say if we are having 5 elements from 0 to this query, we have inserted them in path and we are only processing them once. So first time we might go 2, then again we got 2, and then we only got 1. So this activity we are doing it only for 5 times, not for all the n times for all this path. So this will be only q. So the time complexity is q into n plus q. And why this why our solution is being accepted? Because the constraints are very small, they are only up to 500 only. Yeah, so if it is larger than 500 or something, then our solution might go in TLE. And what is the space complexity for this solution? We have used n over here, we have used q over here, and we have used answer for n, so it will be n plus q, space complexity, right? Yeah, so thank you all.